All right, in this video, we're going to continue with rational equations. And if you could copy these down, they're very similar to what we did last week. First thing we have to do is find our common denominator. I'm going to abbreviate that CD. Okay, so what do we see as far as factors that are different for all of these denominators? I see a V, so I'll write that. What else do I see? I see a 2. And that's about it. So I see a 2 here and a V here. Well, we already had those. So our common denominator will be those two things multiplied together, 2V. So what do we do with this? Multiply it on top here, multiply it on top here, and multiply it on top here. Every single term. Now, we cancel. What we can cancel a 2, or excuse me, with a V with a V. We can cancel a 2 with a 2. We can cancel the whole 2V with the whole 2V here. And now we no longer have denominators. So we can just worry about what's up top. 2 times 1 is 2 equals. V times 3 is 3V. Always writing the number first. Plus a 3. And wow, that got way simpler now, didn't it? 2 minus 2. Get rid of that 2. Actually, you know what I'm going to do? Not what I just did. I'm going to do that. So we got -1 equals 3V. That cancels. And then we divide by 3 here and 3 here. 3's cancel there. V equals -1/3. And of course, I kind of encroached on the workspace of the next problem, but that's okay because I'm doing this on a computer and I can just shrink it down there. Okay. So, great, V equals -1/3. Number 2, let's find all of our common, well, let's find our common denominator, all of our different factors. So I see a 2, I see a P, but I also see a P squared, okay? So I see a 2, I see a P, and then I also see a P squared, but really, whenever I see the same variable, I just take the one with the highest power. So really, it's a 2P squared is what I see there. So I'm going to use that as my common denominator, multiply it on top of each value of each term. Multiply, multiply, multiply. Okay, now we're going to cancel some stuff. What do we cancel, you guys? You know this? So we cancel the 2's. We can cancel 1P here, so just going to leave 1 on top, and then, so that's just P times 1, plus, we cancel the entire 2P squared there, plus the 1, equals, and then cancel the P squareds there, so we've got 2 times 3, which is 6. Wow, that's not too hard now, is it? Subtract 1, P equals 5, and we are done. Okay, number 3. Let's find all of the unique factors in our denominator so we can identify it. Well, we got an x minus 3 here, so I'm going to add that. Oops. What else do we have? Well, actually, this is just 1, so 1 you don't need to include. We always assume that things are multiplied by 1 because really they are. But that's it. We've got our x minus 3, and that's it. Okay. So what's going to happen here is you put this 3 over 1 so that it looks like a fraction, okay? And we're going to just multiply everything by this x minus 3. Now we can cancel. Switch to green here. Cancel, cancel. We won't cancel anything here because x minus 3 doesn't match with 1, but it does match here. Okay, so what we have is 3 equals 3 times x minus 3, right there, plus a 1. Okay, so I'm going to simplify this guy right here. 3 times x is 3x. 3 times -3 is -9, plus 1, 3. Over here still comes down. All right, so let's go up here. We've got 3, I'm gonna just keep that there. 3x, -9 plus 1 is -8. And then we're gonna add 8, add 8. 3 plus 8 is 11, equals 3x. And our final step, we divide by 3 on both sides. 3's cancel. X equals 11/3. Box it up. And we're done. Number 4. Try this one on your own. Okay, all the unique factors in the denominator. Well, now we have another binomial, which is interesting, but this right here is a factor, that is a factor, and this is a factor as well. So all of our different factors are, okay, we've got n minus 1, that's 1. We also have 2n plus 3. Okay, so our common denominator is going to be this times that. Like so. Now what we're going to do is take this thing, multiply it on top of every term. So you can see what'll cancel out here. 2n plus 3. And just for the sake of expediency, I'll take this, copy it, paste right there, multiplying it on top. I can resize that, and then I can paste again, resize it, boom. So you can see what I'm doing. I'm just multiplying this on top of every fraction here. So now you can see what to cancel. I will cancel the n minus 1 with the n minus 1. I will cancel the n minus 1 with the n minus 1 again, and then I'll cancel the 2n plus 3. So now what do we have? We got to be careful here and look carefully at what we have. 2n plus 3 times 1. Well, that's just 2n plus 3, equal sign. 2n plus 3 times 2. Well, I'm going to write the 2 out in front. And then minus the 1 times the n minus 1. So really it's just this. But we need to make sure to keep those parentheses there, because if we don't, then we're going to get it wrong, because we got to distribute that negative sign. Okay, so now right here we've got 2 times 2n, that's 4n. We've got 2 times 3, that's 6. We've got negative n plus 1. 2n plus 3 comes down. Let's combine like terms. What are our like terms, guys? Okay, we got 2n, we got 4n, and we got negative n. Anything else? Nope. And then we're going to combine, obviously, the positive 3, the positive 6, and the positive 1. So let's combine those things. Going up here. 2n, so let's go 4n minus n first. We'll get 3n. 3n, and then we're going to go 6 plus 1 is 7. Okay, so just messing with the right-hand side. Now, I'm going to take the 2n and subtract it on this side, and both sides, making it go off of that side, and I've got n plus 7. And then I just subtract 7, you get negative 4 equals n, and that is your answer. Okay. Goes down a little bit over here, so we have some more room. That is a really cool feature. Okay, last one. Copy it down, try it on your own. So the first step we need to do here is identify all the different factors in the denominator, like we always have been. However, with this question, we have to first GCF factor this and that, well, they're the same thing, so really just one. Why? So that we can see all the different factors. So how does this thing GCF factor? K squared plus 2k. Well, what can we pull out from both? We can pull out a k and a k. So let's do that. Pull out the k, then we got a k left over, and then k cancels there, and we are left with a 2. So k times k plus 2. That is this thing factored. We need to make sure to GCF factor everything first. So what we have as far as factors are k, and we have a k plus 2, and we have a k plus 2 here, but we already had that. So our common denominator will be this, okay? So I'm just going to move this right over here because that is where it belongs. I'm also going to copy this, and then I'm going to paste it up here, and I'm going to multiply it by the top of each one of these terms. Just like this. Okay. Get rid of this little bar here. It's unnecessary. Times 1, times 1, times 3. Okay, well that's cool. Now we need to cancel. Don't forget to cancel. All right, so really this whole thing here is a k times k plus 2. So it's the same thing as this. So that just cancels with that. That's the same thing, right? Because this equals the k times the k plus 2. All right, and the k plus 2 cancels with the k plus 2 there. And then again, this is the same thing as the k times the k plus 2, so those can cancel. Now what we're left with is 1 equals k times 1, which is just k, and then minus, everything canceled there, so all we have is a 3. 1 equals k minus 3. See how much simpler that is? All right, so we add 3 to both sides, and we have 4 equals k, or just k equals 4, and we are done.